So here's another hashtag transcripts gone wrong, courtesy of my university lecture. So this is talking about blood transfusion science, which it's so interesting. I love it. And anyway, back to the transcript. So we're talking about mixed reactions, and apparently he used to be straight. And then after being transfused, we're getting a mixed reaction. So I've listened to that part several times and I still don't understand what he meant. But anyway, what he's talking about is mixed reactions within a tube. Let me lay it out for you. Little scenario. A patient has gotten into a massive car crash, losing heaps of blood. What are the doctors going to do? They need that blood immediately. If they don't know the patient's blood type, which can be A, B, AB, or O, if they don't know that straight off the bat, they need to figure out what it is. And sometimes, patients knocking on heaven's door, like, we ain't got time for this shit. What the doctors will do is they will give them O-type blood. So the reason for that is O blood cells don't have certain labels on their cell surface. And these labels are what interact with the immune system. So if an A, B, or a B get O cells, their immune system isn't going to arc up because the O cells don't have those labels. Anyway, patient's been transfused, they're stable, but we still got to figure out what blood type they are. So in the transfusion science lab, they'll take the patient's blood and they'll run it through some columns. And in this instance, to make it a little bit easier, we're going to talk about forward blood grouping or forward blood typing. So what will happen is that they'll have a mix of cells. If they're A, B, or AB mixed with O cells, they're going to see different reactions. They're going to see a layer at the top and a layer at the bottom of the tube. And these reactions, these layers, are caused by agglutination or clumping. So at the top of a tube, I'm thinking of a particular type, a particular technology of tube. Just bear with me, okay? Just bear with me. Okay, so that's the other half of the group that I was talking about. We're not going to talk about that. We're going to focus on the forward group. So, agglutination will occur if you mix a serum called anti-A. There's also anti-B and anti-AB serum. So, if the patient has A cells, if it's mixed with anti-A serum, anti-A cells going to attack, going to clump, and the O cells will be at the bottom because they don't interact with anti-A. B cells will clump at the top in the presence of anti-B serum. Again, B cells being attacked by anti-B serum. And again, O cells don't get anything. And finally, anti-B serum attacks both A, B, and AB blood groups. And if you can think about the cells having labels, you can see that the O cells don't react to any of these serums. What they do react to, the anti-A, anti-B, and anti-AB are looking for tags on the cell surface, an A, B, or AB tag. So this is from a journal article, and this is the closest thing that I can find to showing what a mixed reaction looks like. So if you look at the top of the B, there's clumping of B cells at the top, but you can see the bottom. Those would be the O cells. Of course, there's a million other reasons why there could be a mixed field inconsistency, but we're not going to talk about that. It's too heavy, We've got the basics down, okay? Also, if there are any other scientists watching, I know that the rhesus system plays a big part in transfusion science, but I mean, to satiate you in general, O negative blood is used in particular. And that's a whole nother topic. Alright, well, I guess I better get back to studying. I don't wanna.